Hi, guys. This is a lesson about astrophysics. As you can see on this whiteboard, I'm going to draw what I'm going to show you, and I'm going to tell you how it is and how it forms. So right now, I'm going to get my marker. I'm going to draw the sun, okay? But I don't have yellow, so I'm going to draw an orange. I'm going to draw the sun, okay? For example, just a star, okay? Draw a star. So when I draw that star, when the star dies, and when it explodes, which is called supernova, the explosion is when it collapses on itself because gravity pushes it down. But how the star's balance is really hard because the pressure of the burning hot core of the sun, which will be in the center right here, is where hydrogen gets fused into, hydrogen turns into helium, and so it makes pressure out. And so that balances gravity. So now if that's stable, now that that thing is stable, then the star will be alive. But at the end of its life, the hydrogen will be tired, and the hydrogen will stop, and the balance will end by gravity winning, which is pulling inside the star, pulling it closer together, and the core burns faster and hotter, making the outer layer swell of the star, causing the star to collapse and get smaller and smaller and smaller until it finally collapses into a really big explosion where it shoots out lots of inside of it, and then it turns into a black hole, which is what we're going to be talking about today. So that's how a black hole forms. Black holes aren't actually the size of the star. They're a little bigger than the core of the star, so that's why the star was a little bit bigger if you're getting confused. Now, a black hole, anything that gets too close, for example, I'm going to draw a little object that's getting too close. If the object gets too close, the black hole will suck it in, which leaving it to not escape, because a black hole is so strong that nothing can escape the gravity. So let's say there was an asteroid. This is the asteroid right now. Then it gets closer and closer and closer. See? Until the black hole rips it apart into pieces. So now it's getting longer and longer and longer until it collides into a black hole. And then the black hole gets a little bit of mass and gets a little bit bigger. That's what mass means. It gets a little bigger. So if you got too close to a black hole, this is going to be a black hole. If you get too close to one, you'll get sucked into it, as I told you. Now, sometimes you're gonna, if you study astronomy and astrophysics like me, you will notice that people will start saying to you that, did you know that there was a black hole in the center of the galaxy? And now, there actually is a black hole in the center of the galaxy. And don't worry about it sucking you in, because black holes aren't very good eaters. So now, what I'm going to draw now is a galaxy, and I'm going to draw a black hole in the size, in the middle of it. Black holes are usually located in the middle of galaxies. And do you know why they're black? Well, they're black because light cannot escape from them. Because light, you have to go faster than the speed of light to escape a black hole. And if you go faster than the speed of light, that can't be possible. So let's say